Properties of logarithms. The first property we'll look at is the log of a product equals the sum of the logs. That's what this first bullet point is saying. So if we've got a product mn, you can rewrite it as the log of mn equals the log of m plus the log of n. And in all cases, the base is the same in all the logarithms. So let's look at this first example. Log base 6 of 36x. We can rewrite this as log base 6 of 36 plus log base 6 of x. And this first expression, log base 6 of 36, we're going to see if we can simplify that using what we learned earlier. We'll set it equal to x. We'll rewrite it in exponential form, so 6 to the x equals 36. We'll rewrite both sides as powers of the same base, so I can rewrite 36 as 6 squared. So 6 to the x equals 6 squared. We can now ignore the bases and set the exponents equal, so x equals 2. So that first one simplifies to 2 plus log base 6 of x. The second example, natural log of ex, of the product ex, we'll look at in blue. And then we'll look at the third one in green, both on the next slide. So we've got the natural log of e times x, and we can split that into the natural log of e plus the natural log of x. Now this first one, we will look to see if we can simplify by setting it equal to x, and then rewriting that in exponential form, e to the x, because the base of the natural log is e, and that equals e, but we can rewrite e as e to the 1. So now we have both sides as powers of the same base. We can set the exponents equal, so x equals 1. So this example simplifies to natural log of x plus 1, or 1 plus the natural log of x. Then the final example, log base 8 of 2 plus log base 8 of 4. So now we're using the property in the opposite direction. We have the sum of two logs. We're now going to rewrite it as a single log of a product. So, and what's important here is that the bases are the same. If we had the sum of two logs with different bases, we could not use this property to combine it into a single log. So combining it into a single log, we have log base 8 of 2 times 4, which is the same as log base 8 of 8. And we will see if we can simplify that. So log base 8 of 8, we'll set that equal to x. We will rewrite that in exponential form. 8 to the x equals 8 to the 1. Set the exponents equal, x equals 1. So that third example just simplifies to 1. Okay, the second property will be the log of a quotient equals the difference of the logs. So here we have a quotient, log base a of m divided by n, and we can rewrite that as log base a of m minus log base a of n. So this first example we'll look at in red. The log base 3 of x over 9. We can rewrite that as the log base 3 of x minus the log base 3 of 9. Going to try to simplify this second expression. I'll set it equal to x. I'll rewrite it in exponential form, so 3 to the x equals 9. I can rewrite 9 as 3 squared, and I can set the exponents equal, x equals 2. So this simplifies to log base 3 of x plus 2. And it's important, when I don't have parentheses like this, what's implied is that x is the argument of the log. The plus 2 is outside of the logarithm. And that is what we want in this example. Okay, we'll look at the natural log of e over x in blue. And then we'll look at the third example where we're going in the opposite direction in green, both on the next slide. So we have the natural log of e divided by x. So this is a quotient. We'll rewrite it as a difference. So natural log of e minus the natural log of x. We will simplify the natural log of e. We'll set it equal to x. The base of the natural log is e, so we can rewrite this as e to the x equals e, which is the same as e to the 1. Set the exponents equal, so that expression equals 1, and this expression simplifies to 1 minus the natural log of x. Then finally, log base 6 of 18 minus log base 6 of 3. So here we have a difference. We're going to rewrite this as the quotient, as a log of just a single quotient. So I can rewrite this as log base 6 of 18 over 3, or log base 6 of 6. If I try to simplify that, set it equal to x, rewrite this in exponential form, 6 to the x equals 6, 6 to the 1, and then set the exponents equal. So this logarithmic expression simplifies to 1 as well. Okay, the third property. The log of a power equals the product of the power of the log. So you can see in this first bullet point, log base a of m to the r, where r is the exponent, we can bring that exponent in front and make it r times log base a of m. So let's look at this first example in red. We've got log base 3 of 3 to the negative 4. So we will take this negative 4 and move it out in front and rewrite it as negative 4 times log base 3 of 3. And we will see if we can simplify log base 3 of 3. We'll set it equal to x. We'll rewrite it in exponential form. 3 to the x equals 3, or 3 to the 1, and then set the exponents equal. So this becomes negative 4 times 1, or just negative 4. Okay, we'll look at the natural log of e to the square root of 2 power in blue. Okay, so our exponent will come out in front, the square root of 2 times the natural log of e. We've already simplified this on a previous slide, so we know that the natural log of e we can set equal to x. E to the x equals e to the 1, or x equals 1. So this becomes the square root of 2 times 1, or the square root of 2. Okay, so we have those three basic properties. Let's use them a little bit more. Write each expression as a sum or difference of logarithms. Well, this first one, mainly the only property that we can use on it is that third property we just saw. We've got log base 2 of z cubed. So I can move the exponent out in front, so 3 times log base 2 of z. And we can't do anything else. So that is what we would leave as our answer. Let's look at the second one. Log base 2 of x cubed over x minus 3, where x is greater than 3. Okay, so basically this condition, x is greater than 3, is just the condition on our domain. So first, we know x can't equal 3 because then we would be dividing by 0. And if x were less than 3, we would have a negative argument in the logarithm, which we cannot have. So x does need to be greater than 3. Okay, splitting it into the difference of two logs, we could write log base 2 of x cubed minus log base 2 of x minus 3. So notice how it really is necessary to put the parentheses around the x minus 3 in that last expression. Otherwise, it would just look like the argument was x. Okay, I'm going to bring my exponent in the first expression out in front. So 3 times log base 2 of x minus log base 2 of x minus 3. And that is as far as we can expand it out. Let's look at the last one in green. So the natural log of x times e to the x. I'll do it up here. So I can split it apart because it's a product. So natural log of x plus the natural log of e to the x. I can move the exponent out in front. So natural log of x plus x times the natural log of e. We've already simplified the natural log of e before. We know it equals 1. So this simplifies to the natural log of x plus x. And again, the only argument in the natural log is that first x. Okay, so now we're going to go in the other direction. We've got, well, mainly differences here, but it would apply if it were sums as well. We want to write each expression as a single logarithm. So in our final answer, we'll only have the word log once. And again, it is necessary for the bases of the logarithms to be the same here. So let's look at this first one. 2 times the log base 3 of u minus the log base 3 of v. So before I can apply the property that has to do with the difference of two logs, I do need to move the 2 that's out in front up to be an exponent. So log base 3 of u squared minus log base 3 of v. And now I can combine it into a single logarithm, log base 3 of u squared divided by v. And that is my single log. Let's look at the second example. Log base 4 of x squared minus 1 minus 5 times log base 4 of x plus 1. So first I need to move that 5 up to be an exponent on the argument. I'm going to leave it as minus, so technically I could choose to move the negative 5 to be the exponent, but then I would have a plus that remains in between, but I'm just going to move the 5. Log base 4 of x squared minus 1 minus log base 4 of x plus 1 quantity raised to the 5th power. And now I will combine it into a single log as a quotient. So log base 4 of x squared minus 1 over x plus 1 quantity squared, or quantity raised to the 5th power. And I can simplify this because I can factor that numerator to x plus 1 times x minus 1. The denominator will stay the same right now, x plus 1 raised to the 5th power. But now I will be able to cancel out x plus 1's so that it cancels out of the numerator and gets replaced by a 1. And my exponent in the denominator becomes a 4. So I'm left with log base 4 of x minus 1 over x plus 1 raised to the 4th. And that is my single logarithm. We will look at the last one in green on the next slide. So we have 2 times log base a of 5x cubed minus 1/2 log base a of 2x plus 3. So let's move the 2 and the 1/2 so that they become exponents on the arguments. So log base a of 5x cubed squared minus log base a of 2x plus 3 raised to the 1/2 power. Now I'll combine the expressions into a single logarithm. Log base a of 5x cubed squared over 2x plus 3 raised to the 1/2 power. I will square my numerator, so it becomes 25x to the 6th. And remember, something raised to the 1/2 power is the same as the square root. So I can rewrite the denominator as the square root of 2x plus 3. And that is my simplified logarithm, or my single logarithm. Okay, this last property used to be much more important than it is today, because back even like 6 years ago, calculators did not allow you to enter a base in them. You were only left to use on calculators the common log, which is log base 10, or the natural log, so log base e. So the change of base formula says if we have log base a of m, we can rewrite it as log base b, so a different base, of m divided by log base b of a. So applying that to log base 5 of 18, I could write that as log of 18, which means log base 10 of 18 over log of 5, or I could write natural log of 18 over natural log of 5. And then we could calculate what it equals, which is approximately 1.796. Now, technically, when we rewrote it, we could have chosen our B, our different base, to be anything we wanted. But traditionally, what was used a lot were base 10 or base E. And back before calculators, tables of logs were provided. And you wouldn't necessarily have the tables for all log bases. So you would want to convert it to a base that you had tables for.